In a museum drawer, a single vertebra sits under cold light, black as if it has been cut from night rather than bone. It does not look alive. It does not even look recent enough to belong to the same earth as us. It came out of a coal mine in northern Colombia, from rock laid down almost 58 million years ago, and for years that was enough to define the story. A giant snake. The biggest ever known. A tropical monster from the age after the dinosaurs. That version is still true, in the way silhouettes are true. It gives you the outline and hides the face. Because the closer scientists moved toward Titanoboa, the stranger the outline became. Not louder. Stranger. What first seemed like a simple lesson in size slowly turned into a lesson about absence, about climate, about extinction, and about one of the most persistent fantasies in paleontology, that if we wait long enough, ancient DNA will eventually tell us everything. It won't. And in the case of Titanoboa, that failure may be the very thing that revealed the truth. The old image was easy to hold in the mind. A snake longer than a bus, heavier than a piano, moving through a drowned Paleocene forest while the world was still recovering from the catastrophe that ended the non-avian dinosaurs. Fossils from Saragen suggested an animal somewhere around 40 to nearly 50 feet long, with a body so thick it would have had to force itself through an ordinary doorway. For the public, Titanoboa became a superlative. The largest snake. A monstrous answer to a trivia question. But superlatives flatten history. They make the past feel finished. Saragen was never just a snake site. It was a window into an early neotropical rainforest, one of the oldest clear glimpses of that kind of ecosystem anywhere in South America. Leaves, seeds, wood, pollen, turtles, crocodile relatives, fish, and the snake itself all came out of the same buried world. And that world was not a copy of the modern tropics. It was hotter. Wetter. Simpler in some ways, yet already unmistakably a rainforest. A place assembling itself after mass extinction. That is the first shift in perspective. Titanoboa was not merely living in a jungle. It belonged to a young kind of jungle, a rainforest still early in its own history. The snake was not an isolated marvel. It was part of a planetary recovery. And yet even that did not fully disturb the accepted story. For years, the animal was still imagined mostly as size incarnate. What happens when a boa lineage is given enough heat, enough prey, enough time? The logic felt straightforward. Cold-blooded body, warmer world, larger snake. Elegant. Persuasive. Perhaps too persuasive. Because then you reach the next layer of the mystery, and everything grows quieter. No skin survives from Titanoboa. No scales. No flesh. No blood. And, almost certainly, no recoverable DNA. That matters more than it seems. In popular culture, ancient DNA has become a kind of delayed promise. Not today, maybe, but someday. A locked archive in bone, waiting for better tools. And modern science has indeed pushed that archive much farther back than many researchers once thought possible. Genetic material has been recovered from ancient environments millions of years old under extraordinary conditions, especially in deep cold, where degradation slows and mineral surfaces can help preserve fragments. Each breakthrough encourages the old hope that the fossil record might someday begin speaking in genes as well as shapes. But Titanoboa lived in the opposite of deep cold. It lived in equatorial heat. And heat is merciless to DNA. Time breaks it. Water helps break it faster. Warmth accelerates the process. Tropical environments, rich with life above ground, are often ruthless to fragile molecular traces below it. The reason that dark vertebra in the drawer cannot simply be sequenced is not a technical inconvenience. It is a physical boundary written into chemistry itself. So the headline fantasy collapses. The ancient DNA did not come from Titanoboa. And that is where the real story begins. Because once scientists accepted that the snake's genes were almost certainly gone beyond recovery, the question changed. The hunt was no longer for a miraculous molecule that would solve everything at once. It became a slower inquiry. If the genome is absent, what remains? What can anatomy still say? What can climate still say? What can the surrounding forest still say? And what can the DNA of other creatures, living and extinct, tell us about the world Titanoboa emerged from? The answer came not as a sudden revelation, but in accumulating waves. The first wave was environmental. Saragen was not just warm. It seems to have been very warm, perhaps several degrees Celsius hotter on average than modern neotropical rainforests, with immense rainfall and a dense, layered forest structure. This matters because Titanoboa's body was not simply large, it was biologically expensive. For a reptile to maintain that scale, the surrounding environment had to support it metabolically. The snake was evidence, in part, for the climate itself. Its body became a thermometer. But if Titanoboa told scientists something about heat, the forest told them something deeper about timing. This ecosystem appears only a few million years after the end Cretaceous extinction. In other words, Titanoboa did not come drifting out of some untouched dinosaur world. It arose in the aftermath, in a biosphere rebuilding itself from shock. That reframes the snake's origin entirely. Titanoboa was not a relic of the lost age before the asteroid. It was a product of what came after. A creature of recovery. That distinction sounds small until you sit with it. We tend to imagine giant prehistoric predators as survivors from older empires, holdovers from vanished reigns. Titanoboa was something more unsettling, a sign that life, after devastation, does not simply return. It reorganizes. It experiments. It fills emptied rooms with new forms of power. The second wave of evidence came from anatomy, especially from the rarest kind of snake fossil there is, a skull. For a long time, Titanoboa was known mostly from vertebrae and ribs. That alone was enough to establish astonishing size. But snake skulls are delicate architectures, built from bones that disarticulate easily after death. They are far less likely to survive than sturdier elements of the spine. When parts of Titanoboa's skull were finally identified, they changed the animal from a measurement into a way of life. The skull suggested a mouth that could open immensely wide, as one would expect. But it also hinted at something more specific. Researchers noted features that aligned Titanoboa firmly with boid snakes and suggested ecological habits that may have been more aquatic, and perhaps more fish-oriented, than the public image of a simple giant constrictor tends to allow. Denser tooth arrangement. Cranial proportions shaped by prey capture in water. Not just a massive snake in a swamp, but a predator tuned to that watery world. Again, the accepted picture shifted. Titanoboa was not merely a supersized version of the modern generic snake in our imagination. It was more particular than that. More ecological. More local to its vanished habitat. And then came the third wave, the one that makes the title feel, at last, less misleading than it first appears. If Titanoboa's own DNA is gone, ancient DNA still changes the story by drawing a line around what can and cannot be known directly. The oldest genetic recoveries on Earth come from exceptional settings that protected fragments through deep time, cold sediments, unusual minerals, improbable preservation. They have shown just how much lost world can survive under the right conditions. But by doing so, they have also made Titanoboa's silence more meaningful, not less. They clarify why a Paleocene snake from a hot rainforest will never yield the kind of molecular confession people once imagined. And once that illusion is gone, a clearer origin emerges. Titanoboa's story has to be read not from resurrected genes, but from comparative biology, the relationships of living boas and anacondas, the morphology of fossil bones, the climate of early tropical South America, the food webs of a rainforest only beginning to resemble the modern one. Piece by piece, the snake settles into a different family portrait. Not a mythic outlier. Not a dinosaur's leftover shadow. A boid giant, close to the radiation of large constricting snakes, occupying a world where the rules of heat, water, and prey availability allowed a lineage to reach a scale no living snake can sustain today. That may sound, at first, like a reduction. As if the mystery has been explained away. In fact, it makes the animal more strange. Because what this means is that Titanoboa was born from conditions that no longer exist in combination. An equatorial greenhouse world. A rainforest still early in its evolutionary history. A landscape recovering from planetary trauma. Waterways filled with large fish, giant turtles, and crocodilian predators. A lineage of snakes entering ecological space opened by extinction and amplified by climate. Its origin was never the simple origin of a monster. It was the origin of an aftermath. And there is something quietly profound in the fact that ancient DNA helps us understand this precisely by refusing us the wrong kind of answer. Science is often imagined as the art of extracting hidden certainties. But just as often, it is the discipline of learning which certainties are impossible, and becoming more intelligent inside that limit. No lab will spool Titanoboa's genome into the light. No technician will hold up a sequence and announce, finally, exactly what it was. The truth arrived in a more sober form. Through leaf impressions. Through vertebrae. Through the architecture of a skull. Through the chemistry of DNA decay. Through the knowledge that some worlds preserve molecules and others erase them so completely that the erasure becomes evidence in its own right. That is why Titanoboa feels different now than it did when it first entered the public imagination. It is still enormous. Still theatrical in scale. But the deeper story is no longer just about a snake that could terrify us. It is about how ecosystems rebuild after annihilation. About how climate shapes the outer limits of life. About how absence can become one of science's strongest facts. And perhaps, too, about how the tropics remember. Not with perfect fidelity. Not with genes intact. but with impressions. Assemblages. Fragments laid down in mud and pressure and time, then darkened into coal country. Enough to tell us that after the end of one world, another began almost immediately to invent new giants. So when we return to that vertebra in the drawer, it has changed. At first it seemed like a remnant of brute force, a fossilized brag from deep time. Now it looks more like a sentence from a much larger text. A sentence about heat. About recovery. About the first great rainforests of South America. About a snake whose origins were not locked in some recoverable strand of ancient DNA, but in the emergence of an entirely new ecological order after catastrophe. The bone is still black under the museum light. But it is no longer silent in the same way. If you find this kind of careful journey into the deep past worth returning to, you can subscribe and stay with us. There are some stories that do not become smaller when we understand them. They become deeper. And Titanoboa, resting there in the dark, is one of them.